Hey everyone, so this video is going to be about the idea of preferential discharge. Now, what is the meaning of the word preference? Which means we choose one over the other. So, in preferential discharge, we talk about aqueous solutions only because they have H plus ions and OH minus ions because of water, so there are two extra ions. So, the idea is that it is the discharge. Discharge means reduction or oxidation, so it's the discharge of an ion at the respective electrode on the basis of the position of the ion in a electrochemical series. So what's an electrochemical series? An electrochemical series is an arrangement of ions, and the position of the ion tells us whether it's going to be discharged or not. So we know there are two kinds of ions, right? It's a cation, which is the positive ion. They have electron deficiency, and there are anions with extra electrons. On the left, you can see the cation discharge series. It starts at potassium and ends at silver. So imagine you have an aqueous solution of, let's say, sodium ions. Aqueous means it has water. Water means they have dissociated to give H plus ions and OH minus ions. So due to the dissociation of water, also known as the self-ionization of water, there's going to be H plus ions in water in any aqueous solution. So out of the sodium plus ions and the H plus ions, H plus will discharge itself because it is lower in the electrochemical series. So H plus ions will gain electrons, it will form hydrogen gas, you're going to see the bubbles of the gas, while the sodium ions will remain in the solution. They're definitely going to go to the cathode, but they're not going to discharge themselves. Similarly, if you have an aqueous solutions containing copper ions, so H plus ions are going to be there because water self-dissociation. But this time, out of the copper plus 2 ions and the H plus ions, copper ions are going to go to the cathode to discharge themselves, reduce themselves, gain electrons, and form copper. Because copper ions are lower in the electrochemical series. Hydrogen ions will remain intact in the solution. They're not going to discharge themselves, even if they go to the cathode. So the idea is the ones which are lower in the series discharge themselves. For the anions, we have another series which starts at sulfate and then ends at hydroxide. The ones which are higher in the anion series never discharge themselves. So like sulfate, nitrate, fluoride, they will never discharge themselves. They will remain in the solution no matter what. So they remain in the solution. They never produce any other compound. I'm talking about the aqueous solutions. Let's recall that. So the only ion that you have left is the OH minus from the water. It will discharge itself. It will oxidize on the anode to form oxygen gas. So let me write it. As it is lower in the electrochemical series. I'm not writing electrochemical, we know that. So we need to know that OH ions will discharge because they're lower. However, the chloride, bromide, and iodide ions may discharge themselves only if it's a very concentrated solution. So sometimes concentration also has an effect on determining which ion will discharge. And that is true only in the case of anions, specifically chloride ions. In O-level chemistry syllabus, you only need to know about the chloride ions. In order to make it more clear, I have two different beakers, two different electrochemical series, electrochemical cells, where I have the anodes and cathodes labeled. So I'm gonna be creating a contrast between two different electrolytes. Imagine in both the diagrams you can see cathode on the left hand side and anode on the right hand side because the negative terminal is connected with the cathode, positive with the anode. Now what's the difference between these two electrochemical cells? One has concentrated aqueous sodium chloride. Now even though it's an aqueous solution, it is concentrated. The other one is dilute aqueous sodium chloride. So the only difference is the concentration of sodium chloride. Both are aqueous solutions of the same substance, but the concentrations are different. You have Na plus and H plus ions as cation in both. You have Cl minus and OH minus as anions in both. So the ions are same, the concentration is different. Similarly, when we talk about the dilute aqueous sodium chloride, again, sodium plus and H plus ions are the cations, chloride minus and OH minus ions are the anions. Now we need to look at the fact that cations are similar and there is no role of concentration in terms of cations. So in both cases, the results are going to be the same. From sodium ions and chloride ions, H plus ions are lower in series. I'm writing it with a purple pen that H plus ions are lower in the electrochemical series in both cases, right? So there's no role of concentration over here. So what happens is H plus ions will discharge themselves at the cathode. H plus ions will gain electrons. They're forming hydrogen molecule because H never exists alone. It's never a monoatomic, it's a diatomic gas. Similarly, in the other solution, the concentrated one, H plus ions will gain electron. They're going to form hydrogen gas molecules. So what you're going to observe is, you're going to observe bubbles of colorless gas around the cathode. You can see the bubbles of colorless gas in both cases around the cathode, which are actually the bubbles of hydrogen gas. So if to confirm, if you add a light and splint, it's going to pop. What happens in terms of the anions? So there's a role of concentration. In the dilute ones, the OH minus ions will discharge themselves. So in dilute solutions, OH minus ions will lose electrons, will oxidize themselves. OH ions will lose electrons, they're going to form oxygen gas and water. So you're going to be observing bubbles of oxygen gas on the anode. So you're going to observe bubbles of oxygen gas, half the moles, but you're going to observe oxygen gas being produced at the anode in a dilute solution. However, in a concentrated solution, chloride minus ions, Cl minus ions, will discharge themselves on the anode. And here you can see the role of concentration. So chloride ion will discharge in concentrated solution to produce chlorine gas, which is actually a green fume, which is actually a pale green fume released on the anode. While in the dilute solution, the OH minus ions will discharge themselves. And you need to remember this difference. Just the word concentrated changes everything. So in dilute solutions, you can see OH minus ions discharging to produce oxygen gas. In concentrated solutions, you can see chloride ions discharging to produce chlorine gas. Now let's try some past paper questions to see if we are, following it. When we are talking about carbon electrodes, we are actually talking about inert graphite electrodes. So let's see the question. It's talking about the aqueous copper sulfate, which has copper ions, hydrogen ions, sulfate ions, and OH minus ions because it's aqueous solution, right? The copper ions are lower in the series. They're going to discharge to form copper at the cathode, while sulfate never discharges. So OH minus ions will discharge on the anode to form oxygen gas and water. What happens to the electrolyte? The H plus and the sulfate minus are remaining in the solution. Since H plus ions cause acidity, the answer is going to be A. It can't be B because it's not becoming alkaline. The copper ions are not, they're not increasing in concentration, so they're actually discharging. So that's why not C as well. This question says, apparatus setup as shown in the diagram. It's talking about concentrated aqueous nickel chloride. So nickel ions, H plus ions, chloride, and OH minus ions. We can see that it's talking about what occurs at the electrode X. Electrode X is connected to the positive terminal, you can see, so it is actually the anode. Now it can be either chloride or OH minus ions. What occurs at the electrode X? Chloride ions will discharge on the anode because it's a concentrated solution. We just talked about it, that in concentrated cases, chloride ions will discharge themselves to form chlorine gas. So chloride ions are oxidized. Chloride ions are never going to reduce themselves, so option B is very stupid, and C and D are equally stupid, by the way. Let's look at this question. It says rubidium is above sodium in the reactivity series. Above sodium means very higher, so very hard to discharge. It is saying what is formed when concentrated aqueous rubidium chloride is electrolyzed. So it's going to have rubidium ions, chloride ions, H plus ions, and OH minus ions. Now since rubidium is a lot higher in the electrochemical series, H plus ions will discharge itself to form hydrogen gas on the cathode because it's lower in the series, right? And since it's a concentrated solution, chloride minus will discharge itself to form chlorine gas, and chlorine is going to be evolving at the anode. So the answer is going to be at the cathode you'll see hydrogen, and on the anode you're going to have chlorine gas. Let's look at this question. It says a solid deposit of element R is formed at the cathode, which means R was a cation because only cations go to the cathode. When an aqueous solution containing ions of R is electrolyzed, which statement about element R must be correct? So R was lower in the chemical series, that's why it got discharged on the cathode, otherwise it would stay in the solution. So R forms negative ions, I'm so sorry, otherwise it go to anode. R ions gain electron at the cathode, definitely, because it's discharging itself. So it has to be B. It can't be C because on the cathode only electrons are gained. Cathode is for reduction, not for electron loss. If R was above hydrogen, it would not have deposited on the cathode, so R has to be lower. So it's B for ball, because R ions are gaining electrons on the cathode, and R is lower in the series. This question says, what are the products when concentrated aqueous lithium chloride is electrolyzed? So I'm concerned that it's lithium ions, chloride ions, H plus ions, and OH minus ions. Now lithium is a lot higher in the electrochemical series, so hydrogen would be the one discharging at the cathode because hydrogen is lower in the series. And when we talk about chloride and OH, it's a concentrated solution, so chloride ions will discharge on the anode, chlorine gas will evolve. So at the anode you'll see chlorine gas, on the cathode you'll have hydrogen gas because hydrogen was lower. So the answer is gonna be at the cathode hydrogen and chlorine. A for apple. It's gonna be A for apple is the right answer. So yeah, I'm accurate. Let's look at this question. It says a current was passed through concentrated aqueous potassium chloride. So it's gonna have potassium ions, chloride ions, H plus and OH minus. The question is asking which entry in the table is correct. Ions moving towards. Now guys, remember, all ions move. It's not like they don't move. They all move, but it's just a matter of discharging. So when they're talking about moving, please consider all the ions. All the cations go to the cathode regardless of their position. All the anions go to the anode regardless of their position. It's only the discharge, so the answer was D for that one. This question says, what are the products formed at the electrodes during the electrolysis of molten magnesium chloride? So magnesium chloride is only magnesium and chloride ions, no water, no H plus, no OH minus. So over here magnesium will be formed at the cathode by reduction, and chlorine will be formed on the anode by oxidation. So I hope these MCQs are clear to us. In the coming video, we're going to be talking about the active electrolyte, active electrode electrolysis. So stay tuned guys. Thanks.